So welcome to welcome to Office Hours of Arbitrage Season 3, Episode 7. It's a different format than I usually do. This is a hour-long special on feature neutralization. This is a topic-specific stream. I've been promising to do this for a long time now, but over the weekend, I got the feature neutralization code to work. WiggleMuse was correct. My overclocking was causing my blue screens of death. And when I went into my BIOS settings and turned those off, magically my computer ran better. And there's no noticeable difference in performance, but I didn't blue screen to death when I ran the feature neutralization code. That was what really was holding me up. So I have to thank him for helping me out on that. Also, I asked JRB and WiggleMuse to join me today. And thankfully we have Michael Oliver too. I'll probably lean on him a little bit. Not too bad though, because he's been flogged lately. So we're going to leave him alone. But in case we have follow-on questions, he can help us out. And we have a bunch of good Slido questions too. But what I did over the weekend is I took the Twitch example models and I feature neutralized at 100% and 50%, trained on Nomi and trained on Kazutsugi, and submitted them. So I was really hopeful that the scores would be out so that we could look at it in terms of what it looks like when you train it, what it looks like when you do the metrics on validation, and then what it looks like on live data. So hopefully by the end of the stream, we'll have something for you with live results. The other thing that I'm trying to figure out is how do I pass the links to myself from one computer to the other. So we're gonna figure this out live, I guess. And now my mouse, oh, there we go. So we already know I have Twitch_training. This is the model that I uploaded with the example model that we built in the last Twitch tutorial. That is no feature neutralization. Train on Kazutsugi, evaluate on Kazutsugi. In addition to that, but the model is Twitch_example_KAZ. Yeah, that's a nice little pop-up actually. And the next one, I do full neutralization. So, and it's descriptive in its title. Okay, Twitch_EX_Kaz_FULL. Guess what that is? Full feature neutralization. Yes, and then you can guess what the next one's going to be. Half. It ends in half, so it's Twitch example Kaz_half, just like above. Numerator.ai/Twitch x Kaz half. So that's my naming convention. Okay. So you can check those out, and when scores come out, we'll be able to look at how they do on live data. And thank you, WiggleMuse, for posting those in Zoom. They actually pop up in the video, so I'm glad about that.
Do you have Nomi versions of these as well?
I do, but I don't want to complicate it yet.
Okay.
Yes, I have all of these made on Nomi as well. And I guess how I'd like to start is to talk about feature neutralization from a big picture view. What it even is. What is feature neutralization? And right now, the most qualified person to answer that question is the one who wrote about it in the forum. That's JRB.
So this is my understanding of feature neutralization. So essentially, the idea is that you don't want your models to put too much stock into individual features. And feature exposure is a measure of how much weightage your model is ascribing to individual features. So ideally, you want a model which has a very balanced perspective on all the features. Tries to use all the features with equal importance. And that's not something which is possible in practice. So feature neutralization, which in statistics is called residualization, is essentially trying to build a naive linear model and subtract out the predictions of the linear model from your model. And that seems to decrease the feature exposure because it essentially reduces the collinearity between the features and your target, your prediction.
Okay.
Does that make sense?
How about there exists signal in the data just by the nature of it?
Oh, right. Yeah. Yeah. I think one of the problems with this is anything that I can talk about this, I think I've already spoken about it on your daily scores and chill.
It's possible. We're treating it like we've never talked about it before. So let me take a shot at it. The data has certain factor loadings that are present already. And if your model predicts certain, we'll call it factor loadings, and that becomes overweight based on what's already present in the data. If you neutralize against it, in other words, you take the OLS solution for the live era, subtract that out of your predictions, you've become orthogonal to the linearity that exists in the data already. Now, I feel like I already went too complex. I think I overdid it. But
yeah,
I'm pretty sure I said
think,
it right at least.
Yeah, one of the things I noticed was that if you actually take the training targets and measure the feature exposure between the features and the training targets, it's actually not too bad. It's actually super good. So I have a feeling that the training data in many ways is quite neutral to the targets. It's just that the easiest thing you can do with the data is make linear predictions. And
Right.
The models we build are also very tempted to make linear predictions. And this probably is the reason why feature neutralization tends to improve things.
Yeah.
I'd love to have Michael Oliver's perspective on this.
You're trying to rope him in. I'm trying to save him from having to talk too much. But you just unmuted yourself, so I'm going to let you go for it.
Yeah, I was just going to say I agree with everything that's been said. I think that's been described fairly well. I mean, another simple way you can say it is just it's making your predictions less correlated with the individual features
that are already present in the data.
That are already present in the data.
Right.
Less linearly correlated.
Yes. Right. Yeah, because we're looking for interactions between features for like an XGBoost is already doing that. That's exactly what a tree model does. It looks at interactions of the columns. And so taking out those linear relationships that are pre-existing in the data helps you to avoid overfitting on those linearities in the live results. But Senator Doran Cap has a question, and I don't know if we want to do questions yet, but I'm gonna see how this goes. Why is it so why it's so important became I don't quite follow the wording of that. Why it's so important became neutral to a linear regression. Why is it so important to become neutral to a linear regression?
Why neutralize against the linear model? Why not neutralize against the example model?
So I'm going to take a stab at it. Let's say that one of the columns is market beta. We want a 0 beta. But if the feature or the set of predictions that we're making for this particular round, the average beta is 0.4, we have to subtract that out to achieve a 0 beta. Now I'm kind of guessing the math won't work out quite like that because our feature set is not continuous, right? It's discretized, but I think that's essentially what we're doing is we're trying to take out the existing factor loadings in the model. And I say factor loadings, and that's kind of a new term that I haven't really used before, but that's where my quantitative trading comes into play here. So if you're already exposed to these things because you have not neutralized and you predict based on certain factor loadings, you may overshoot. And taking out the OLS solution helps to avoid that.
So since we are already answering questions, I think I'll take a stab at answering Honeycomb's question. Is there a formal name for this type of processing? Would love to be able to explore some academic papers on this topic. I think I've already mentioned this. The technical term in statistics for this is residualization.
Yeah.
And I think that's what you should be looking at. I can post the term in Twitch chat and Zoom chat.
Yeah, there was some idea that this was unique and new to NumRI, but that was just because of the verbiage being used at the time.
It's still pretty weird.
It is.
JRB did point to one paper, and you pointed to one paper, and that's 2 papers we've been able to find so far. If there's a whole library of material about it, particularly not just with residualization, that's not that weird. In other words, taking a linear model and subtracting it from a different model is not that weird. But we are taking predictive features in the data that we're using to make a predictive model and essentially getting rid of them, which is a weird thing to do. And I don't think we're completely theoretically justified here. The reason to do it is because it works. And what we mean by it works is that it's reducing risk, because it doesn't strictly make your model better. Your core scores are going to go down when you neutralize, but they will be more consistent and they will probably avoid those big burns. That's the idea. So your Sharpe should get better, and it's just safer. So should you do it absolutely all the time, every model? I don't think so. Should you use some models to balance against not neutralized or lightly neutralized other models or things you're ensembling together? Yes. So it's a tool that can lower your risk. And it is kind of unique to what we're doing. And we've had some stabs at explanations of why it would even be a thing. And the best one I've heard is sort of that low-hanging fruit arbitrage thing, where if an obvious feature, not the person arbitrage, the actual arbitrage.
Yeah, that's my bad.
If the features we're given are all apparently, since we don't know what they are, fairly standard or obvious features that everyone making models in the world would tend to use. Therefore, if one of them is doing really well at predicting the market, then everyone is suddenly going to use that feature like gangbusters, and it will not predict the market in the next following period because everyone's chasing that alpha. So this will set up a dynamic where features cyclically work and then don't work. And so we're basically looking for more hidden interactions between features that will be more stable over time, hopefully. And that's the idea anyways.
Yeah, I'm cool with that. So we've described what we're doing. Some of us have actually done some experimentation on it. Jeremy, this is where you could talk a bit about what you did in your forum post in terms of doing some evaluation across. You replicated the example model and you evaluated with and without feature neutralization. Can you just describe what you did? And then I can go through the mechanical process of showing how it was done.
Right. Okay. So it wasn't just the example model. Mike P gave me a whole bunch of predictions from a whole bunch of models. I think a couple of hundred models. And so I tried essentially looking at the results with and without neutralization. And I plotted the validation Sharpe of these models versus the feature exposure. So the more you feature neutralize, the lesser your feature exposure is. And there seems to be a linear relationship between having lower feature exposure and having a better Sharpe. So
And
that was that.
Your validation results showed.
So the higher the feature exposure, the more likely you are to burn, which is something everybody knows.
The higher feature exposure you have.
Yeah, the more likely you are to, not do very well.
Is that strictly true?
Consistently. Not necessarily. I mean, I guess this is a lesson which we all.
The more likely you are to burn badly when you burn, I would say.
Yeah. So adding to what Vikram said, this is something which almost everybody here knows, which is validation 1 is too easy, right? I mean, you can build an ensemble of linear models trained per error and do very well on validation 1. And validation 2 is quite hard. So, I guess that's the case with a lot of live rounds as well. You have live rounds where a linear model would do very well. And I'd imagine a feature neutralized model wouldn't do that well in such rounds. But feature neutralization in some way is a way of getting some burn insurance.
Burn insurance.
Now, if we go into the sort of weeds of it, would you? The question is, do you want to neutralize the targets before you train, or do you train after? Do you neutralize your predictions? I've only been neutralizing my predictions, but I believe there are quite a few people who've been also neutralizing the training data with interesting results.
We're going to
So
try that
I'd love
in
to
the
hear
next
from such
Twitch
people.
tutorial. I haven't done it yet. I've created the target. I haven't
There
done
are
it
3 ways to do it. You can neutralize the targets beforehand. You can neutralize the results after the fact, which is the easiest thing to do. And somebody asks Slido, does it matter what your modeling algorithm is? And no, it does not, because once you've got a set of predictions, you can neutralize those no matter where they came from. Even if they're just random numbers, you can neutralize them. Neutralizing the targets beforehand would have an effect on your modeling, so certain methods may not react well to that. And then the one thing that I mentioned that I have not heard others talk about is you can neutralize the actual data itself and leave the targets alone, which is what I've done. And that needs a little explanation because
Yeah, what?
in other words, you would take your 310 feature columns and one by one neutralize them to the targets. But then the question is, in case you haven't thought of Ed, is what do you do when you've got new live data? Do you then neutralize that, or how do you neutralize that? Because you don't have the targets to neutralize against because you're predicting the targets. And the answer is surprisingly, you don't do anything. You just use the data as it comes, and it seems to work okay. Because as JRB just mentioned, each individual feature is fairly neutral already. The feature exposure you get in a finished model tends to be it's an additive thing from putting all those features together in your modeling. So when you neutralize each feature individually, it doesn't change all that much, but it does change. And I've made some pretty decent models that where I featured neutralized or did the data first, but let the targets alone, and also did it afterwards, or also did not do it afterwards, depending.
I've got a question.
Yes.
So if you're doing it this way, why can't you keep the coefficients from your OLS models and use that to neutralize the live data?
You probably could, but I didn't. And this sort of goes along with what I was musing about, I should say.
There it is.
In the Data Discourse and Chill a couple of days ago, where I was just saying embrace randomness. And that's a thing that it sounds like you should do, and maybe you should do it. I haven't actually done it. It sounds because I tried it without doing it first, and it worked very well. So a lot of times when you're supposed to save transformative features and then apply them to your data before you predict on the new data, often if you don't do that or do it independently, like in case of scaling, it works even better because it just adds a little sense of randomness, which tends to make it more robust. So I would try it both ways, but
this
be afraid
also
of not
reminds
doing
me
it.
of something you've been mentioning a lot and I've never tried, which is you neutralize on an error-by-error basis, right? Unlike the rest of us, we just do it the whole.
I don't even know. Computationally, I don't even know how you would do it.
Yeah, that's a big matrix.
Because you're neutralizing on the whole training set all at once, or what are you doing? And I think you gave a little hint about why that doesn't even make sense to me. You said, well, you want to get rid of every bit of, the linear. In other words, when I'm doing neutralization, I want to neutralize the predictions against the data that's generated those very predictions. So especially in a live area, you have to do it after the fact each week. So are you saving coefficients again there, or neutralizing, or I just neutralize against my predictions against the data from that era. And that's what I have in mind doing that, not some grand removing of a linearity that, I don't know, is inherent in the model or something.
I would say
linearities that are there.
I could be wrong, but My intuition was that each era has about 5,000 rows, and that's too little data to even train a linear model.
No, it's not. No, it's not. An OLS only needs
it is not.
how many degrees of freedom you
Yeah.
have. So you need what? It's 310
It's,
columns plus 2 to have a statistical significance.
My default on everything is error-based. Anytime I have a new idea, especially because I'm not doing boosting, I'm not doing deep learning, which I guess doesn't matter.
I'm curious to hear Michael Oliver's take on
Yeah,
this.
yeah.
I think he just was saying something.
Yeah. I generally agree with JRB that it is a little bit for 300 coefficients. It's not very much data to estimate your covariance matrix. And so you could play around with like regularizing it, doing like ridge regression instead or something like that. Or you could do something like you could estimate the covariance matrix using more than one era. You could use the data from multiple eras or like multiple preceding eras. You definitely don't want to do this. You don't want to use eras after the point you're neutralizing in time to estimate the covariance matrix, because that will be cheaty. But yeah, I've played around with doing things like using multiple eras to estimate the covariance matrix for doing the linear regression. So you basically use the covariance matrix from your previous, from a bunch of data, and then basically use that to regress out the ones in the current era.
Well, statistical significance, you don't need that much more.
Statistical significance is bullshit, and you shouldn't use it for anything.
Also, yeah,
Oh,
in terms
right.
of the
Shots fired. Shots fired.
in this case, though, basically I want an overfit equation. In other words, if I'm neutralizing 100%, I just want to neutralize completely. I don't care if it is like a predictive.
Yeah, I mean, you can argue it both ways. Like
it seems like the proportion variable would be the thing to play with there.
Potentially. I mean, you could think of it like the way two features covary. If you assume that their covariance is relatively constant over time, over eras, when you're trying to regress them out, it maybe is better to use a covariance matrix estimator for more data, so that you're not, because it is overfit in as you're saying, and maybe you want that, but maybe you don't, because it is an overfit point estimate from one era. Because if you just want to take your feature exposures all the way down to 0, you have to do the overfit way, but maybe that's not what you want.
That's mainly what I've been doing, so it's been fine. Also, it also seems to run counter to the whole idea. The reason we are doing this is because the features don't act consistently era to era. They go up, they go down, sometimes they're good, sometimes they're bad. So I don't really care about the other eras. I want to neutralize against this era fully, because I don't want information from previous eras telling me what to do, because it's not consistent. But all of this is, again, not super really well theoretically justified, and there's a lot of randomness in here. So anything you try is sometimes going to work better than some other thing you try. And it's tempting to say, therefore, this thing is better. But
I would also just point out in the analysis and tips notebook, the analysis and tips notebook that was given by the team does an error group by. And so for as long as I can remember, the default has always been to do what the team does. And so that's how I'm going to do it until they suggest we do otherwise. And especially given that each era has a different regime, potentially, if you lump the eras together, you aren't getting the pure signal out per era.
Anything at all that you do, any crazy technique you come up with that lowers feature exposure and yet preserves signal somehow, is going to be on the continuum of the effect that we want here. Some of them are going to work better than some others at various times. And I don't think any of us can prove this way is best. And as I was also saying the other day, in terms of randomness, a lot of times you think this is this is what makes sense to me. That's what I do. That's common sense.
Yeah, there's also
And then
that.
I'll do the exact opposite of that, and it just works better. And I don't know why, but whatever.
Oh, it's a good way to test the null, right?
I would do lots of empirical tests on all of this. So people are asking, why is this better? Is this one better? I don't know. Nobody knows. You decide.
Yeah, Honeycomb asks in Twitch, if we were to consider multiple preceding eras, how do we deal with the live era? And exactly. So that's why I think group by era is the more appropriate way to go, because each era stands by itself. But I get what you're saying, Michael Oliver. You could use more data.
I'm not saying you should do these things. I'm just saying there are things you can think about and other things. But yeah, for the live era, you can all you need is the features to calculate the covariance matrix.
Correct.
And you have them, and so you have the previous features from the previous eras as part of the test. So you could definitely do it for live in that way. It's something I played around with. It looked semi-promising, but it didn't seem to. It seemed to. Yeah, I haven't looked at it in a while, but
that's fine.
Just giving people ideas.
Yeah, no, that's what this is about. This is about talking about feature neutralization, because I was a skeptic. I still am. I was really hoping I could have some scores, because that would help me buy in. Okay. So I'm just saying, I'm kind of stalling just a little bit because I really want scores to come out. But all that aside, we talked about what's going on. There's some questions going on. Let's look at the mechanics behind it, because perhaps people are visual learners and they need to see it. This is the example model. Okay. What am I doing here? So I have my modules that I'm bringing in. I have the training data set to be download. I set it as a data frame. Okay. We've got XGBoost as XGB regressor. This is the example model itself. This is exactly how they design it. And so learning rate 0.01. Anyway, this is familiar to you if you have seen this model before. Dependent variable is defined as such. This follows exactly what I've done in previous Twitch tutorials. Okay. So this convenience list function defines the features so that we can pull them out. And I define X and Y, and then I fit on X and Y. So that's the train data. Remember, I'm not treating the errors separately. This is a pooled model in that sense. But this recreates example predictions very closely. So we do that. I take a naive correlation score. This is not the official one, but this is what I've been using for the Twitch tutorial to this point. I want to get the validation, so we predict on the validation data here, create predictions. I've done this, so you can see what I get. I get a 2.6% correlation on Kazutsugi. And if I take, this is actually on Nomi. So that's what, if you train on Kazutsugi and evaluate on Nomi, you get 2.6. If you train on Kazutsugi and evaluate on Kazutsugi, it's higher. And that's the reason why you need to be prepared for the release of Nomi on scoring, because you could do worse. In order to create the predictions, we have to download the tournament data, define your feature set as X tournament. We need to store the predictions. All right, we're catching up. So that just finished training the example model. I was doing that in the background because I knew it would take a little bit. Store the predictions into its own variable, and I put it into a CSV, example predictions Twitch. That's just how I named it. I save that file, that gets uploaded. Speaking of uploading, let's take a look at what that is. This is the example Kazutsugi model. All right, 233. That's our running correlation in MMC and correlation with the meta model. Now, let's look at the main page so you can see how the submission worked for that one. All right, let's just make sure I have the right one. This is the diagnostics. This is what you should look at after you've uploaded your predictions. Right, validation sharp. We get some measure of how they do relative to others. I don't put a lot of weight into this because people do funky stuff, but it's a good indication of how you're doing. If you have extreme results one way or the other, it warrants further investigation. Okay. Max drawdown, this one is important. So we have a negative 7.5%. That's very high. Personally, I want to see that much closer to 0 as possible. And we have our core MMC sharp. Average MMC, there's no MMC because this is the example model and lots of people have it. I'm sure lots of people are staking on it. And our correlation with the example predictions is 97.6%. That's pretty close. Michael Oliver has been suggested, perhaps, that the team use a random seed for the example models that we could perfectly replicate it. Do you think that's possible someday, maybe?
I think it's possible. I don't know that the random seed behavior, if you set a random seed, if it will be consistent across Linux and Windows.
Still. I agree. Yeah, it's pretty rough. it's pretty rough. But you know, at any rate, I think it's close enough. Some people disagree and they'd rather download the file and pull the team generated example predictions and use those. That's okay.
Yeah, I mean, it's I don't think there's. I guess we could provide the XGB, like the binary file for the model.
I didn't think about that.
Yeah, I think that's a good compromise.
Maybe
that wouldn't be too bad.
Maybe.
I believe it's not binary anymore. They switched to JSON recently.
They have their own binary format.
That's true.
They used to, yeah. I think in the newer versions, it's a text-based format, just like how it is in IGBM.
Okay. Yeah. Whatever the default when you just use save model in the current versions, is probably what we would do.
Yeah. So I wanted to show you that's the flow. Okay. So we create this example predictions file as a CSV, upload it to the site. Those are the numbers that you get. I don't know what just happened. I think I dragged on accident, but that's okay. So now I need to neutralize these predictions. Okay, so the second notebook, from a previous Twitch tutorial, I showed you how to reduce the amount of memory used when you load in the file, and that's what joblib is used for here. We're going to import this dictionary so that Pandas knows to convert the feature columns and the target column to float 32. So that's what's happening here. We download the tournament data, and we do the convenience feature or the convenience list function to capture the features. The code is basically what's been provided by the team. Okay, that's what this section is. So we import the min-max scaler because your predictions need to fall between 0 and 1. And this function does it for you. All right, so we define a function, neutralize. The default settings for neutralize is it accepts a data frame. You have to tell it the column that you're going to use. The by, right, corresponds to here on the features, and then the proportion. Proportion is how do you want it fully neutralized is 1, half neutralized is 0.5, and not neutralized at all is 0, but you wouldn't run this function at all if it's going to be 0. You would just submit your prediction file. You have to pass it some things. So this works with pandas. So you need to use pandas in order to get this to play nice. So if you're not already using pandas as part of your pipeline, I highly suggest you modify your code so that it will play nicely with it. Once I've defined all these functions, I'm importing my own prediction file, which we generated in the previous step, which it's done, so that's good. So it's example predictions Twitch, and I overwrote it on accident because I copy pasted. But we're gonna read that in. I'm gonna merge it with the tournament data. So I have tournament data, but I'm gonna call it preds, right? And it's the pred file .prediction Kazusugi because that's what I predicted. But I'm gonna create a new column called neutralize preds. Right. So from the tournament data frame, I'm going to create neutralize preds, which is tournament data.groupby. So I'm taking for each era in the tournament data, I'm going to apply a lambda function. This lambda function treats x as normalize and neutralize. So it's going to do that for each x on preds, which we defined here. And we're going to use the features as the OLS solution set, and then we're going to fully neutralize it. So the number here is 1. This is where you change it. If you want to do full, it's 1. If you want half, it's 0.5, and 0 would be not at all, but you would just skip running this function. All right. And finally, we need to define the scalar, so min-max scalar. So we have to convert it back to 0 to 1 range because you will have negative values after you run this. So you have to make sure that you get everything back into a 0 to 1 scale. And then we get tournament data neutralize preds is equal to scalar.fit transform. So once that function's done, we have to transform it back into 0 to 1. Below that, I kind of renamed some stuff. So I create a new data frame called tournament_submission, and I want the ID column in the neutralize preds. I'm going to rename it to prediction Kazusugi, and then I'm going to save it, Twitch example fully neutralized. Now I've uploaded that. Okay, I've uploaded this. So this all runs, and let's go back to here. This is Kazusugi fully neutralized. Now I uploaded it. And you can see the metrics. The validation sharp is up quite a bit. Validation mean, 0.23. But I want to really point out the drawdown, because to me, this is arguably the most important part. Max drawdown went from -7% to -2.7%. That's a huge performance boost in terms of its drawdown. Also, notice we had almost 0 MMC before. Now it's point. We gained some. Remember, it's the example prediction. So even when you neutralize it, it isn't going to add that much extra signal, but it did boost the MMC. And the correlation with the example predictions, that was shocking to me when I did it the first time. It's only 57%, well, 58% correlated. I find that to be very interesting.
That's
So
a little off because he never fixed that metric, but for this particular example, it's pretty close to what.
what do you mean by that? Because it's not by era?
Yes.
Okay.
So because you are scaling it, it's pretty close to the real number you should be getting, which I think is about 55, 58 or something. I mean, your model's a little different, but if you had certain other types of data that is not as separated between the eras, you might get something like 22 on this metric, and then you see when you submit it live, it will be like 60. So
Joe wants to know, how is columns and by different? And what I think he's getting at is what is going on right here. So if you're looking at Twitch,
columns really ought to be singular. Column is the thing that you want to neutralize.
That's what I thought.
By is the matrix of data that you are neutralizing against.
There it is.
So by is all of the features, and column, which should just be column, is going to be the one column, which is the targets or the predictions,
right?
Which either you are neutralizing against.
And we're
assuming they're all part of the same data frame,
right?
Which is a little weird in the Python version.
I call it target and by in the code that I posted on the forum post. I think columns is it's not.
I got very confused by that when I translated.
Joe, thanks for pointing that out. I'm not going to do it right this moment, but I think that is worth rewriting because it isn't quite descriptive. Now, I wanted to show if we did the same process, right? So the way I did it is I'm just taking my already existing CSV file of the predictions, and I'm reading it back in, taking my predictions, and then neutralizing it and creating a new CSV to submit. You could probably do all this in one pipeline if you had the same model and you wanted to do different types of neutralization. But that's if we did it on full neutralization. We saw the metrics. What does it look like if we did it on half? So I did that too. So you know what? I wish I had snipping tool. Let me just grab it real quick, because I want to save these diagnostics. This is my favorite tool in Windows. So I want to keep these metrics here. That's fully. So we're going to go to CAS half. So this is half. Now we can compare full versus half on the submitted metrics. Okay. So our validation sharp goes down slightly if we only do half. Our validation mean is up. Neutralized mean slightly higher. Right? Standard deviation slightly higher. You notice it's a little lower here. That's good. You don't want a high standard deviation. That's risk. Feature exposure goes from 0.2. If you fully neutralize, is 0.02. That's a huge difference. That magnitude is significant. And the drawdown. So it's actually not that different in terms of drawdown, which surprises me. We were at 0.07 on the non-neutralized, and we go to negative 0.04, but the fully neutralized is negative 0.027. Okay? Now, look at the core MMC chart. This is interesting. Core MMC on the half is actually higher than full, but the MMC mean is lower. Now, I'm not sure that we can infer too much from the way they calculate MMC because it's against the example predictions themselves. So it's MMC compared to just the example predictions. It isn't indicative of what you'll see in live, but it's probably meaningful against the example predictions because guess what? These are the example predictions. So in that sense, we're getting some information out of it. And the correlation.
These
go ahead.
Things at Rocket Chat. If you saw my 0, 50, and 100% versions in Rocket Chat, those are post-neutralized against the neutralized the example predictions that you can download in the file.
Yep. So here we have the correlation of the example predictions. This to me is very, very telling. Half neutralized is still 91%. Fully neutralized is 57%. Call it 58. That's a huge difference in change. I was really, really, really hoping we could jump over and look at the live performance, but the scores aren't out yet. So let's hop over and look at Slido. Slido had some great questions that I wanted to go through. JRB actually has the first question. When is the tournament switching to scoring on Nomi targets? Michael Oliver stepped off. I haven't heard anything different. It should still be Halloween. Honeycomb, is there a formal name for this type of processing? You'd love to be able to explore some academic papers. So we talked about that briefly. GRB posted in, I think you put that in Twitch chat, residualization. We're just taking out the OLS and looking at the residuals. And Jeremy, am I still not convinced by feature neutralization? I was hoping to be able to answer this question with live results because I feature neutralized all of 15 of my models and submitted it over the weekend. And also these models are deployed on the Twitch example models, and we could have looked at those live performance and done some relative comparisons. And yeah, it's an N of 1 because we're only having 1 day, but it will still give us a relative rank in terms of here's not neutralized, here's fully neutralized, and here's half, and you can just you can look at it. It gives you some indication. Yeah, we want a resolved round to really see what's going on, but it still is informative. And because I put them on, I submitted them, so now everybody can track it. So that's also a benefit. You can just check out its performance every day if you're curious enough. Jeremy, by doing such analysis on diagnostics, aren't you overfitting on validation data? Maybe an arrowized CV would provide better insights. So this is, I have my hypothesis here is that one of these three will be more performant. And my actual test is on live data. The validation metric, since I've looked at it 3 times, each model hasn't looked at it 3 times. I've just evaluated it in a different way 3 times. I don't think I'm doing any p hacking in that way. But I'm going to let that hang out there and see if any of my science friends will want to reject my paper.
We're showing the diagnostic sets we have, but we're not making our decisions solely on that.
Yeah, I'm not making decisions on validation. That's a good point. It's like the first out of sample, and now I'm paper trading with the live data results. That would be the final arbiter of
not
success.
Making final decisions anyways.
Yeah. So I hope that got to your Twitch question there. Jeremy, you have another question. What features to neutralize and when? To what proportion? You have a multi-part question. That's fine. Are the Sharpe ratio and max drawdown the main indicators of good neutralization? And what else? So what features to neutralize? All of them. You can do subsets of features of the features. Like maybe you only neutralize against intelligence, or only against charisma, or only intelligence and charisma. That's up to you.
Or
I'm trying
the ones that you have high feature exposure against.
Yep. I haven't gotten too advanced.
Probably about to say.
It's possible, yes, that would be the way.
So many.
And Michael Oliver also put out something with. Go ahead one more time.
I posted code for doing this, which is essentially take the top K highest exposed features and neutralize against them.
Okay. Yeah. So that's another way of doing it. All of these things can be tested, and I suggest that if you're evaluating different ways of doing this, decide what your null hypothesis is. So for me, my null is that my baseline models are still really good, and I need the feature neutralization to perform strictly better in order for me to switch. And so I'm going to validate that over the course of the round. And so all those other things, they need to be tested separately. I'm not going to do that because I have all my models are built. But if I had one candidate model, then I would have 14 different things that I could potentially test on one model. But I'm not going to do that because I think it's too much slicing and dicing for my taste. So I'm either doing fully or not at all, and that's my test.
Michael Oliver's back. Nomi.
Oh yeah, when are we going to get scored on Nomi?
So we should be sending out an email about that in a couple days, but it's looking like the 14th.
And Jeremy, another part of your question was, are the Sharpe ratio and max drawdown the indicators of good neutralization? Well, in terms of what I see on validation, yes, I'm looking at Sharpe ratio, looking at autocorrelation, and I'm considering max drawdown. I don't want to see very large drawdowns. That to me is not good. Not good. But I also don't want to lose out on upside.
I would look at Val2 in particular. If you neutralize and you're not getting better on Val2, assuming that you're fairly not great on Val 2 to begin with, as most of us are with their base models. If you're doing great to begin with, then good for you. But most of my results are very bad on Val 2, and they all get better with neutralization. If it doesn't get significantly better on Val 2, I would maybe use a different one, or just tread lightly with that one until you test it more, because Val 2 is also pretty unique, and maybe we shouldn't rely too much on it. But it's an example of what a heavy burn era is like, and you want your neutralized models to do better in burns, because they're going to do worse in the good times, the easy times, and that's just how it's going to go.
So I wanted to show the.
So, wait,
Yeah,
I
go
wanted to
ahead.
say one thing, arbitrage. So I actually think intermediate levels of neutralization probably are the best for what you want for consistency. So I think just neutralized 100% versus not neutralized is not the best test of whether or not it's a good idea.
Okay.
Yeah. Also, something which Michael Oliver mentioned earlier, which is a really good idea. Regularized linear models are pretty good. So that's something you should be trying.
Maybe. I'm doing the test that I'm doing because, again, I follow what is given from the team. It's been my practice all along, and they do 100%. I'm doing 100%. If I don't like what I see when scores do finally come out, they're still not out, I can adjust. So that's the benefit of.
And that's the big question, is how much do you neutralize? And I think a lot of these things we quibble over, should you do error or not error, or should you do this, should you do that, basically come down to the same thing. You could achieve probably the same effect with some value or proportion. There's 100% neutralization, and then there's everything in between.
Yep.
Like somebody suggested on the forum, to use a regularized linear equation instead of the pseudo-inverse version, and then optimize on some metric, which sounds fine. It's just a question of what metric do you want to optimize on, and then it adds a lot of other questions in turn, because then you're burning data and doing cross-val and that sort of thing. So.
Well, one thing, I'm going to switch over to the second computer real quick. So this is something that's been on the forum for a while, the metrics. So if you pass in your validation predictions and run it through all of this, you get the graph and you get the metrics on the bottom. This is the fully neutralized. And so the maximum drawdown is less than 2%. I like to see that. And the number of negative errors, I also like to see below 5. The example model has 5 negative errors, if I remember correctly. And I want to see a few errors that hit pretty high. So I want to see some good upside and minimal drawdown. So I like the way that the predictions do fully neutralize on validation data. And I think Val 2 looks pretty good. So I'm a fan of the way this looks. In terms of performance, the NumRI Sharp is 2.82. I like that. I like to see that a lot. That's a pretty good number. Will it look like this in production? Don't know. We got to wait and see. So we have to be patient. But I wanted to show that. I believe I put this up on my Twitch GitHub, so that at least is available. You can run that too. All right, we're back on.
I don't know if anyone's mentioned this too, but an alternative to feature neutralization is just putting feature exposure penalties in your as part of your cost function, so that you are learning a model that has lower feature exposure rather than doing it at the end. Which, yeah, it's an alternative.
That's another office hours special.
Yeah,
let's not complicate the matters more than we have already. I have a couple more Slido questions. Jeremy has another one. Any difference in how to approach feature neutralization between a tree-based boosting and a neural net model? Not really. I mean, it's the same setup. You just have to decide for yourself if you think that after neutralization that the performance gets better or worse. We'll see. You have to test it yourself. I don't think that anybody's going to be able to answer that question.
After the fact, it doesn't even have to be a model. You can neutralize any column of numbers against the feature. So
that's true too.
It's totally model agnostic if you do it at the end.
Joe says, please show metrics. I already did. Which is better and why? We won't know until we have live results. Sorry. You're going to have to check it after the stream. Anonymous asks, is it possible to apply feature neutralization on any machine learning algorithm? For the sake of this tournament, yes. if you can generate predictions on the data provided by Numerai and you come up with a single column of predictions, you can neutralize it. Can this work for any machine learning tournament, which I think is what the question was trying to ask? I have no idea.
Well, I'd say you could do it for any regression problem.
Yeah, regression problem. Yeah, I think that's a good way to frame it. Yes. Anonymous. I tried to scale the predictions between 0 and 1. The min converted to 0 and the max converted to 1. Yes, that's correct. My question is, why did I get the same correlation? How about my math
Because
folks?
it's ranking correlation. And
Rank.
That is because correlation, like I said before, is scale invariant.
Yep. It's all converted to rank. So it doesn't matter what you feed it. It's gonna order it high to low and then come up with your rank correlation.
Covariance is scale invariant. Standard deviation is scale invariant.
Yeah, even if it was Pearson correlation, it wouldn't matter if you rescaled it.
GRB. Following up on my last question, could we perhaps wait until we have a resolved round or two, since 5 more slots were open before switching to Nomi? And I think you just found out that.
I think that's going to be the case. I think the latest round is, okay, let me just take a look. Round 233 is resolving on November 11th. And Michael Oliver said
14.
it's going to start on November 14th. So we'll have one resolved round, which is good.
Okay. Cool.
Well, I'd love to, but
I got to run to another meeting. So.
Yeah, I know you got to hop. It's cool. Thanks, Michael Oliver. We appreciate you.
See you guys.
Honeycomb, the GitHub Twitch metric notebooks Sharp is multiplied by square root of 12. I'm annualizing the Sharp ratio because that's how I want all the stuff to come through. So when you multiply by the square root of 12, you annualize the metric. These arrows are monthly. And so you have to multiply by the square root of the time scale. In this case, it's months. So you do square root of 12. It puts it into an annualized Sharp ratio. And yeah, so that's not strictly the case for the live rounds because while they are monthly, there's 4 of them, and I have not solved that issue yet. Thanks again, everybody. So that's a wrap for season 3, episode 7. All right, everybody, have a great day. See you in Rocket Chat and tomorrow for Daily Scores and Chill. I appreciate y'all.